Good afternoon again. I resume the talk right now with the recollection of a simple concept called the quality chain. If you see the slide here, I have the external customer at the top of the diagram there. Inside I have the process, which is the factory or the organization that is trying to provide the services or the products. And of course, I've got the external supplier from which I receive materials, labor, machinery, technology and so on and so forth. That's the external supplier there. Inside, notice I've got a whole chain of people. They in turn are customers, suppliers and so on and so forth. So from the moment I enter the shop, I buy something from the external supplier, then I do conversion. I do all these little balls there. They are actually the conversion balls. Then I end up doing this. Each of these is a transformation unit. Just like the total thing is a transformation unit, these little balls, they are also transformation units. If any of these balls malfunctions, if any of these units, if it malfunctions, that means any of the suppliers is not able to do its job, ultimately the external customer is going to suffer. That's like something you've got to remember. So what is it that we recognize here? We recognize the role of internal suppliers. These internal suppliers, they are the people who are supposed to be taking care of all the internal customers. And there are many internal customers, as I just mentioned to you. They are all strung up in a chain. And these people, they all have to be happy. They all have to be, it's got to be made sure that their requirements are met just like we are trying to meet the requirements of the external customers. Each of these internal customers, they have to be happy in order that the final customer, which is the external customer, is going to be happy. Now, locating quality problems, where do I begin? As I mentioned to you, customer complaints, warranties, these are like large areas where I can find what the problems are. I can also begin my work on quality by doing benchmarking, which is like my operations going on right now. I compare my performance to another company that is in comparable business. And I try to find out, how do they do their business? And are my costs comparable to his? Is my productivity comparable to his? Is my finished quality level comparable to his? If it is not, then there is something I'm doing that is not good enough, because he's probably going to outcompete me in the marketplace. I could also begin by doing 7 tools training. I could also do something called the quality function deployment. That's like an input, a major input to designs. And there is, of course, I can tackle problems by doing Taguchi experiments, which I'm going to show you somewhat later in this series of talks. I could work on continuous improvement projects, which are like Kaizen projects. I could also always do PDCA, which is what Deming wanted us to do. What did Deming ask us to do? He gave us, again, just to remind you, Deming gave us the PDCA cycle of quality improvement. And he gave 14 points for the transformation manager to worry about. Juran came along, he gave us the quality trilogy. That is like something where I need to focus on in order for me to be able to deliver and delight a customer, deliver to and delight a customer. I need managerial breakthroughs. That's also something that I need. I need training and I need cost of quality. These are the trilogy. I've got the breakthroughs, training and cost of quality. Those are the trilogy there. Then of course, Feigenbaum gave us total quality control. That has to be applied at all stages. Ishikawa gave us quality circles, which is a group of people. They come together voluntarily. They look at some shop problem. They try to find a solution to it. And in the process, they might be using 7 tools. Some of those 7 tools they might be using. Phil Crosby told us it's very possible for us to justify action on quality, preventive action on quality. And then, of course, quality becomes free because I remove defects and therefore I do not have losses. And Taguchi gave us some simple ways of designing experiments and conducting trials to make sure I improve processes and I produce good designs. I also make sure that I produce right on target by recognition of the quality loss function, and I come up with something called robust design, which is when the product sustains its good performance throughout its life of use. Deming's crucial observation, Deming actually made some crucial observation. He said many times managers tend to operate by the flavor of the month style of operation. Many times they tend to emphasize short-term profits, and many times they worry too much about performance evaluation at every stage. And they lose sight of the fact that we are doing it all to try to satisfy the ultimate customer who is out there. And also we may have transfers and so on within the company, because of which again constancy of purpose might be lost. And many times we only worry about visible figures, for example losses or scrap and that kind of thing. And there may be various types of costs that I may be worried about, and I might be worried about warranty costs. These are actually things that Deming observed, and Deming said these actually are caused by poor quality. And Deming had a number of other obstacles also. They said these are the problems which are there in the company, because of which they are not able to move toward quality. For example, very few companies really do long range planning. They really do not have excellence or examples of excellence that are propagated within the company. That also they do not have. And they believe that technology alone is going to transform everything. Nothing else. No philosophies are required, no orientation is required, and so on and so forth. They also believe that problems are different. There is no real basic similarity in two different problems, and so on and so forth. Similar problems are solved as if I have to reinvent the wheel every time. So the challenge is there to come up with a solution more than anything else. Obsolescence that is there, and reliance on quality control department is like, these are the places where inspectors basically, they are the ones who are trying to assess the quality of producers or products that have already been produced. Our emphasis is really, many places we are trying to meet specifications rather than trying to do something that's fundamentally different. And many times we do false starts. We start a program but do not follow through. And many times actually we have unmanned operations. These are problems where I really need some human intervention, but I do not have them. If you do a good job, and these are on various criteria, you can look for an award, and these awards are nationally recognized. For example, if you show good leadership, if you show good strategic planning in regard to quality, if you really have focus on customers and also focus on the market, if you utilize information and if you analyze that information, if you do good HRM, if you do good process management, and if you have also some linkage between your efforts and business results, you could apply for the Malcolm Baldrige National Award. And that's like one award. There is another award called the Deming Award. This is a Japanese award, and I'm going to be giving you some more details later on. But for right now, I'll just briefly mention that the Deming Award, it's really emphasizing use of statistical methods and quality assurance. So this is like there. This is very, very important. But I should also tell you one thing. Awards are meaningless unless you can translate those awards into business results. Unless you are able to do that, if you just get awards, if you hang them on walls, that's not going to be good enough for your business. Yes, a few people will see that, and a few people will probably appreciate, yes, you must have a well-managed company in place. But it does not necessarily always have a link to business results. That's something I've got to worry about. So just winning awards is not enough. TQM actually is a way to try to create customer-focused organizations. And for that, all you have to do is look inside your company. You'll find a whole bunch of internal customers. They are there. Just as you are worried about the external customers, please also worry about internal customers. And there are many of them, and they're spread around in the different departments. Because as you saw that quality chain, you saw that picture of the quality chain, which basically said there are a whole lot of people that are dependent on what other people are doing. Two modes of quality control are there, and you can read the details. There is the detection mode of quality control, which is like something goes wrong, and then you find out that something has gone wrong. And from that, you get a signal that I've got to take some action. That's like one way. The other way is more proactive. The first one is reactive. The detection mode is reactive. But the proactive mode is the prevention mode. Basically, very little inspection is required. Quality control is done right at the source. And we try to eliminate problems and potential problems. That's what we try to do. This impacts cost directly. This also helps improve sales, and it's much more competitive. So do not really put too much effort on detection. Try to see if you could take some preventive steps that in turn will remove the necessity for doing detection. If you look at the transformation process, we got all these as inputs: people, capital, energy, materials, and so on and so forth. And the outputs are going to be goods or services. That's all I really can sell in the marketplace. It is the transformation process that I have to manage. And to be able to do that, I have to really have a process focus. This is something I have to do. I have to look at problems, issues where there are deviations, and I have to look at the transformation process itself. Is it unstable? Are there a lot of fluctuations in the process? These are a couple of things that I need to worry about. If I do that, if I have process focus, I have to really look at all the inputs in the process. Then I have to look at the transformation box. And the consequence is going to be look at the output and see if the input is doing its job. And that's going to be the efficiency or the dexterity or the expertise, in fact, with which I'm able to manage the transformation process. If I'm able to do that, it's going to be a big job done. So there are these causes or factors. For example, if you look at a particular occasion when I've got a process to manage, and all I'm doing here is I'm producing 3-inch long bolts. These are the bolts that I'm trying to produce. These are bolts which are used in some machines, and I'm producing those 3-inch bolts. The inputs to produce these bolts are, obviously there's some role played by management, maintenance, measurement, machines, methods, manpower and materials, of course. These go as input into that process there. What is the output? The output is beginning to be the length of the bolt, and that's got to be 3 inches. But in effect, I end up producing bolts that are of variable size. And this is the distribution. If this is too wide, of course, I'll not have 3-inch bolt. I'll have some that are 3.5, some that are 2.5, some that are 2/4, and so on and so forth. And that is not something that's going to be fit for the final use of the process. If my variation is going to be too high, the next process is going to have trouble. So I cannot really control quality by looking at the output only. Output is this. I have to really go back to the process. I have to look at the materials also. I have to control all the factors that go into this. This is what I call the process focus in managing quality. There is, of course, the scientific way of managing process, which is like listed out. You identify and define the problem, you study the existing solution, you generate possible solutions, evaluate the alternatives and choose the preferred one, you implement, and then sort of what you really do is you implement the improvement that you have thought about and measure the results, evaluate and revise it if it is required. That's like your old PDCA. Otherwise, you return to step 1 and start again. Deming's PDCA does this, and the latest method, which is the Six Sigma DMAC, it also does things that are quite similar to this, except that the methods are more sophisticated. You are still approaching the whole task in a scientific manner. In fact, I could do this. I could really do process improvement and quality control. If I could put this in a nutshell, I'll say apply scientific methods and use tools, use the right tools, which is like use some of the general tools, use some special tools, and use some very fine grade tools. And I'm going to be giving an example here. The general tools like team building and so on and so forth, those are your general tools. Your coarse grained tools are process flow chart and so on. I'm going to be describing these to you again. And the fine grained tools are like Poka-Yoke, DOE, design of experiments and so on and so forth. These are fine grained tools. These are the ones that I utilize when I get into this. There are obviously going to be some obstacles in implementing TQM. For example, communication may be poor, and it's also possible people may view quality as a quick fix for business. They might think there may be other ways to try to fix the return to good profits and so on and so forth, and quality is probably just a quick fix. It should not be seen that way. Emphasis on short-term financial results, that's also an obstacle to TQM. And there may be political reasons why people may not support your thing and so on. And obviously there may be poor training, and also process knowledge may be poor. And I'm going to be giving a handout for that. I have a full page display. I've got a full display which gives you a pretty decent idea of what it's really there in terms of knowledge of a process to be able to reach the point when the process can perhaps be even automated. And that's a level of knowledge that you rise to. You rise to a particular level of knowledge that's extremely good, extremely well controlled, well understood and so on. And there's a slow climb to get there, starting from something that's very, very basic to something that is truly sophisticated. Like the way they designed this little digital watch. This is a pretty sophisticated piece of equipment. And if all processes ran like this, we really would not have any problem at all. And that's better than Six Sigma, by the way. Obstacles in implementing TQM, there is, of course, these problems are there. Company-wide differential quality is lacking, strategic plan is lacking, customer focus is lacking, Employee empowerment is not there. Time to devote to quality initiative, that's also lacking. There is no proper leadership, and there is not enough motivation because the dollars are not visible. The dollars gained are not visible. So what is the summary from all this? You can really see I have the summary of TQM right here, the 4 or 5 points right there. But TQM is the great foundation. Something you have to remember, that if you are moving into quality, begin with TQM. And obviously, it's not going to be the complete answer because TQM does not make the dollar incentives visible. For this, I need to have a more focused process, which is Six Sigma DMAC. And we'll do that as you get into this. I provided you with some links, and these are websites that you can refer to. And all you have to do basically is type these, and you'll be able to get some more details than I provided you here. In a nutshell, TQM is a culture, it's not a program. And there are some examples. You can go to the website, again I've given you the link there, and find out the story of Southwest Airlines, how they became customer oriented and so on and so forth. Approaches to attain quality, there is obviously the traditional approach, and there is obviously the world-class approach to doing this. The world-class approach is what we are really after, and it is really the result of the process. The product is the result of the process which makes it. If the process is correct, the product will be good, and there will be no need to inspect the process. And there are some other methods also which have been incorporated along with TQM, which are also utilized. For example, lean production, teams, flexible specialization, and diversified quality production. These have all come from different places. People who also worried about quality. Besides the Japanese, many other people also worried about quality. It has come from there. And you can also read this up on either on internet or in some good book on quality. What is the role of management here? They are the enablers, they are the culture setters, they are the enablers, they are the culture setters, and they are the supporters. They are not dictators. And to try to get these details, you have to really look up Deming's writings. And Deming has spelled this out in his 14 points. That's like one place you can read up about this. And also, total quality is also about people with new ideas for quality. People have to be empowered, and good communication has to be there in order that people who are probably one of the most sort of live resource, they can also participate in the delivery of quality. And there are several initiatives that I've listed out here which you can also utilize when you're trying to involve people. That's also going to be possible for you. TQM really should guide all functions that you have in the company. So if you look at that, it can really get into concept formulation, finding out exactly what is it that you want to deliver as a product or a service. So you go after the concept itself, proper management, proper control of it, and improvement also. Deming and many others, they gave you a lot of other stuff, and there are certain things that have to be done alongside doing it right the first time. Designing quality into the system, which would be through methods, through equipment, and through training. And please remember, prevention is much better than detection. That's also something we have to do. What is it that quality involves? There are going to be 2 or 3 layers of this. Quality is the responsibility of management, and the emphasis on customer orientation that we cannot really skip. This is also something that's very important for us. Defects, are defects really useless? Defects are really, some people think they are treasures because they contain data. And the requirement in TQM is going to be a top-down commitment. I mean, I cannot really tell you how important it is for the top man to talk in terms of quality satisfaction, customer satisfaction and perfect quality, customer delight and so on and so forth. If the top person uses that language, it's going to be permeating all the way down. And this two-way communication is very important. The top man should also verify it's been understood at the bottom line. And there are going to be many different tools that we'll be using. Some of these tools are ingrained in TPM or TQM or supply development or re-engineering and so on. And there are others that have come from other areas. Like for example, JIT. JIT basically, although it counts on perfect quality, JIT requires the supplier to have perfect quality. And it really is a big help in supply chain because you can bring in the goods and you can take those different parts, the caps of these pens, for example. If these caps were supplied by a JIT supplier, you can take any of those caps and you can put them straight onto your product. It would be a perfect fit. So JIT really requires perfect quality in all the components. That's something that is required by JIT. For quality to begin with, I've got to have concepts, I've got to have management, I've got to have control, I've got to have improvement. All these are going to be there. They are really required by thing. And again, I should emphasize this. Deming spelled out the wisdom. And Deming's 14 points, if you internalize them, they are listed out here. And I've gone through them before, and I'm again showing them to you in order for you to understand that these are very, very important. And any one of these could be understood. If you go into the literature, you'll find details on any of them. There are, of course, 9, 10, 11, 12, 13 and 14. They are all going to be there. These are the 14 points that are there. Deming also talked about 7 deadly diseases. And these also I've mentioned in the beginning. Obstacles are there and so on and so forth. Other quality experts, they also have given us many different tools. And these are all spelled out. And my slides are going to be basically reminders. And from here, we reach the point when we actually want to judge, do we really have TQM in a company or in an organization? And the questions are just this. Are top people directly involved? Are they talking quality? Does this company have strong customer orientation? Are they solving problems by systematic methods? Do I see everybody involved? And is the theme of continuous improvement in place? If it is not there, of course, I don't really have TQM in that company there. There are various ways to assure quality, and the least progressive one is the one that counts on inspection, that is on the left hand side. This is the one that is least progressive. And the most progressive one is the one when I'm really talking about quality improvement proactively. And there I'm talking about continuous improvement, I'm talking about all the good things done in a preventive manner. This is really the most progressive way to try to improve quality. Slowly moving toward quality assurance, what do I see? I see a process that is affected by many different factors. It turns out that various sectors in the industry, for example, we've got manufacturing, we've got services, and now the latest, we've got software. We've got manufacturing, we've got services, we've got software. Manufacturing, it turns out, is farthest ahead in terms of assurance of quality. Services, for most services, in most situations, we are still inspecting. We're doing quality control by inspection when it comes to services. And when it comes to software, we are doing only testing. We do not have much control on the process. So both services and software, they have really not gotten much into process management. But if you look at manufacturing, it is farthest ahead. In many cases, manufacturing has already exceeded Six Sigma. That's like something we have to worry about. Now look at the problems. This is like, there are 2 problems in this display here. This is the distribution of the output. And I've shown you in one of the earlier graphs, this is the area, this is the region where I've really exceeded what we call the lower specification limit. I've fallen below the lower specification limit. On the x-axis here, I've got some quality characteristic. On the right hand side also, I've exceeded the upper specification limit. So I've got off-spec material. So I've got off-spec material here and off-spec material here. The traditional view of quality management was, do not try to produce anything that falls in the off-spec area. But what is the modern way of managing quality? It says, try to locate the target. Try to locate where the target is. The target is where customer satisfaction is going to be maximum. So try to locate the target, which is mu, right there, which is really next to mu, right here. That's where the target is. My production should not be off target. In fact, this is the bias in the process. The bias is the lack of accuracy. This is like one problem. One problem with production is that production is not accurate. The average does not coincide with the target. Average is off and the target is somewhere else. So there is like lack of accuracy or poor accuracy in this process. The second problem with manufacturing is this spread is wide. That actually is hinting toward poor precision. Poor precision is also another problem there. So I've got 2 issues here. One issue is, the first issue is I lack accuracy. The second issue in manufacturing is I lack precision. So I've got two issues here. I lack accuracy and also I lack precision. Both of these have to be taken care of. I should have proper accuracy and also I should have as fine precision as possible. These can be achieved. These have been done. These have been studied scientifically very, very well. In fact, we use control charts online when a production system is in operation, and through that we try to get quality that is accurate and also that is precise. I have a picture here to again try to distinguish between accuracy and precision and also give you an idea of what happens with an untrained crew. If I have an untrained crew and let's say I'm shooting, and the game is basically to try to fire shots at the target. The target is right in the middle there. That's where the bullseye is. This is the picture of the bullseye and this is the target area. Anything inside the dais, this area here is within specification. Notice here an untrained person, he fires quite a few shots here. The average actually which is shown by this little distribution here, it is off spec. It is basically off target here. Off target means I'm lacking accuracy. And notice also some of the shots have gone beyond specification. This is because precision is poor. I've got wide variation in the shooting of these shots there. So this particular performance lacks not only accuracy, it also lacks precision. Look at this process now. This is another shooter who has been trained to aim correctly. So therefore he's got accuracy. But again the spread is wide and his shots are really widely spread. This guy, he fires shots and there is poor precision, although he's got, on the average, he's on target. This is also not good enough because I really want to shoot the bullseye every time. Look at this guy, he's firing his shots and they're all very close by, but they're again off target. So I'm lacking accuracy here, but my precision is pretty good. And look at this fourth guy, he's firing his shots, the average is right on target and all the shots, they are pretty tight, pretty close to each other. So I've got here accuracy and also I've got precision. This is what you find when you go to manufacturing. If you go to manufacturing, you'll find sometimes the manufacturing process is losing accuracy, or it does not have accuracy, or it has got poor precision, which is like this bell curve here. The tails are in the off-spec area. So I've got poor precision. Both of these are problematic and I've got to do something about them. So if you look at a real process, you will find that I've got really a combination of poor accuracy and also poor precision. I cannot go to a marketplace like this. In fact, because it turns out that these red objects here, which are off spec, they cost me money. What is the cost of quality now? Let's take a look at this concept called the cost of quality. There are four components of it. I'm going to be describing them to you as I move into it. The first thing, of course, we have to remember is whenever I've got quality being taken care of, I involve a bunch of inspectors. So I've got appraisal cost. Appraisal cost is there. This is the cost of inspecting the item. And there's going to be some money spent here in trying to make sure that I inspect the goods that are produced. So if I've got production done, if I'm producing whatever it is, I produce CDs, I produce any of the objects which I'm going to sell in the marketplace, many times I've got to do inspection. And that's not going to be free of charge. It's going to cost me some money. So I've got my appraisal cost here. Then I've got something called internal failure cost. This is the cost of scrap and rework that I have before I make a shipment. Before I ship the product out, I may have some scrap that I produce, and I may have some rework that I have to do because of QC people. QC people rejected some of the items which I have to rework perhaps, or fix them a little bit, touch up here and there and so forth. Only then I can ship them. So I've got some internal failure cost. That's through your scrap and rework. Then I've got external failure cost. These are the costs. I'm going to be giving some details. This is the consequence of poor quality products or services delivered outside. Now this is now in the hands of the customer. So I've got cost here in terms of extra inspection cost. I've got cost here in terms of recap. Basically it's going to be scrap and rework. And then I've got these external costs which are suffered by the customer. Now, if these are going to be high, I'm not going to be in business for too long. My profits are going to be hurt. Is there some way by which I could reduce this? That's actually done by spending money on prevention. If I do that, if I spend money on prevention, these balloons, these three other balloons, they are going to shrink. This is going to be costing me some money, but there's going to be a strong ROI because of the reduction there, the reduction there, and the reduction there. Let me show you some details. Again, I tell you that these are costs. These are visible costs. These are your internal costs, internal failure costs. Many of the external failure costs, those are here. These are your external failure costs. And many times these are not visible and they're very difficult to quantify. I'm going to give you some details here. So this slide here shows you what different failure costs are. And I mentioned here the internal failure costs and the external failure costs. Alongside, of course, I have my appraisal cost and I've got my prevention cost. Prevention cost is really the place where the company should spend its money. Both of these lists, in fact, it turns out that internal failure cost, external failure cost, appraisal cost and prevention cost, together they compose what we call cost of quality, and that's shown in this graph here, this slide here. I've got scrap, rework, they are direct costs to me. They've got warranty costs and product liability costs, they are caused by external failures taking place. Then I've got inspection cost, which comes under your appraisal cost, and of course the good costs are these: process improvement costs, product simplification costs, or training costs. These are going to be my prevention costs. If these increase, then I've got decline in appraisal cost, I've got decline in external cost, external failure cost, I've got decline in internal failure cost. So this is the best place to spend money. The best place to spend money is an ounce of prevention, and that's going to be worth a pound of cure. Again, there is a summary of exactly what I said earlier. So again, you can read these and you can again reinforce what exactly is going on there. Something that is a misconception in the world, in many companies, is that probably spending too much money to try to get perfect quality is not worth it. In fact, what many people do without measuring the real cost. Now, I'm saying this, they do this without measuring the real cost. Without measuring the costs, they draw a picture on paper and they show you, look at the red curve here. The red curve basically is showing you that here I've got some cost, which is a minimum. What is this cost? This is the total cost. This has got your internal failure cost, it got the preventive cost, it's also got the external failure cost, it's got the appraisal cost also. All those four costs, if you put them together and you construct this total cost, some people who do not really know what the real costs are, they will tell you that perfect quality is going to cost you too much, and it's better to try to compromise and provide and produce at some level of quality which they call optimum. That's going to give you the minimum overall cost. This is the false notion. What was done was the Japanese looked at their real cost, and what they found was they looked at their real cost. What they found was good quality led to benefits in the marketplace, and they were able to benefit by expanding their sales and so on and so forth, and good quality also led to lower losses. Both of these turned out to be savings for the company, and the result was this, that the total cost did not really climb up back again, but the total cost got minimized as you approach 100% quality, as you reached a level of defect that was zero. If you had zero defect, that means if you had perfect quality, that's where the total quality cost actually came down and became minimized. So this is quite different from the picture here. Here the picture is shown to be, the optimum point is shown to be at a place where quality level is really not zero defect, it's somewhere off. So you're living with a certain level of poor quality. But what the Japanese were able to show was, as you approach perfection, your total cost actually becomes lower and lower and lower, and the best point to be is pretty close to the perfect cost. There is another view of looking at your costs, and that is called what we call the Taguchi loss function. What Taguchi said was, you talk to a customer, and I give this example all the time. I have a shirt here which is size 42, and that was the perfect shirt. I could really tie my button there, and I could also put a tie there. There's no problem at all. I could use this shirt which is size 42 perfectly well. But suppose a friend of mine, he went to Bombay, and he bought me a nice looking shirt, the material was good and everything else, and the cut was nice and everything, except he did not really know my right size, and he came back with a shirt that was size 44. My size is 42, but he got a shirt for me that is size 44. Unfortunately, the situation is this: although it's a great looking shirt, I'll not be able to use it because I'll have to have the collar open all the time. Because if I try to tighten it, the collar is going to be loose, it's not going to be looking so good. The same thing might happen if he bought me a shirt that was size 40 instead of size 42, which is my true size. My true size is my target. If you come back to the picture here, size 42 is my target. That's where my losses are minimum, my satisfaction is maximum. If I go toward size 42, then I go to size, if I go to size 44, 46 and so on, my dissatisfaction with my shirt is going to rise. Maybe it will be at a point where I'm going to throw away that shirt. I'm going to try to find a friend. In fact, I have no friend who is so fat that his size is 46. So probably if this shirt size turned out to be 46, I'd just have to junk it. Or I may take it to a tailor and ask him, somehow do some, cut and paste or whatever they do. I'm not sure what the tailors do. But I'll say resize the shirt and give it to me because I like the material and so on. First, I'd like to use that shirt somehow. But do adjust the collar before I use it. On the other hand, suppose my shirt size was loose, was tight, and therefore I ended up with a shirt that was size 40 or size 38 or something even below that, size 36. I'd never be use these shirts, never be able to use these shirts. The result is this: again, my dissatisfaction with the shirt that I bought would go up. Now, generally speaking, what happens when you specify something? When you try to convey your requirements, we try to sort of say, well, if I'm buying something, I'm going to give you an upper spec limit and I'm going to give you a lower spec limit. And anything in that area, anything in this area is okay. And anything outside, on this side or on this side is not okay. But anything inside is going to be okay. This is a general perception. Whenever I'm conveying my requirements or I'm talking to a customer, I ask for a specification. I say, give me your specification. But what do? We normally say, well, my size is 42, that's my target. So I tell him that my target is this. Please see if you could provide me something that is size 42. If you provide me anything different from that, you must have noticed that when you purchase shoes, your ideal size is your ideal size. It could be 7. If we got something at 6.5 or 6, you won't be able to use that shoe. And again, if it is 7.5 or 8, again, you will not be able to use a shoe. So in fact, your dissatisfaction is going to go up as you go away from the target. If you go this way or if you go this way, this is your dissatisfaction. And your dissatisfaction is minimum when you're right on target. This is a message that actually was given by Taguchi. And let me spell that name for you. Taguchi is a Japanese quality expert who ended up telling us society always incurs a loss the moment performance goes off. It goes to the right or to the left of the true or the ideal value. This is something that he conveyed by using this, and now I'm going to be using the slide that's on the screen here, the Taguchi loss function. This picture is for the Taguchi's quality loss function. That's this picture there. It's a way to try to convey to other people what quality really is. Then there is something that we also have to remember. There's some issue of ethics also in quality. That also is something that we've got to remember. Substandard work may be there, and some companies may have the tendency to pass it on to the consumer and hope that he will not notice. Defective products may be passed on, substandard product services may be provided, poor designs may be passed on, shoddy workmanship, that also may be passed on, substandard parts or materials may be used. But you have the knowledge of these things, and if you don't tell the customer, if you don't take corrective action, that is plain unethical. Not only it is bad manners, it's also unethical. You don't deserve to be in the marketplace. You don't deserve to be commanding the same respect that an honest businessman does. Because your customer has some trust in you. If you break that trust down, you really don't deserve to be in business. This is something you've got to remember. I'm now going to be entering another area where I'm going to be illustrating to you some tools and techniques which are utilized in TQM. These are also the tools that are utilized by people who work in quality circles. Let's start by going into what we really are after. TQM, again, like I mentioned to you earlier, it's a culture, it's not a program. And it's a culture for orienting your mind, somewhat differently. You'll start thinking of, like the top man would be involved directly. You'll have strong customer orientation. The moment you have a problem, you'll apply basically standard methods or proven methods or systematic problem solving methods. Everyone in the company would be involved in trying to tackle the problem, and you'll have the theme of continuous improvement. These are like, if you're practicing TQM, you'll be doing these things. Let's see how we do that. Again, I don't have to remind you again, these are the things that you should see the moment you have TQM. TQM encourages problem solving at all levels. In fact, this could start right at the shop floor. This could go all the way, depending on the level of or the seriousness of the problem. It could rise right to the level of where strategies are formed by top management. It could do that. There are certain techniques which are utilized. What is the focus of these techniques? They all try to reduce variability. There is something that each one of these tools tries to do. They are data based, and some of the fancy techniques are techniques like statistical process control, SPC. There are some really fancy methods like design of experiments, that's also there. But the bottom line is you must have management commitment to be able to supply these tools, the trainings and so on. What are some of the tools? I have a list here. I'm going to be giving examples of each of these tools. There's a flow chart, then there's the checklist and the histograms and so on and so forth. Let's start this journey. The very first tool is the flow chart. It's the flow chart, and what is it really? It takes you from the left to the right, showing you the steps of the process. So I have material received which is stored somewhere, then I do some inspection, then I make some decisions, then basically I return. If I found some defect, I return it to the customer or to the supplier, or I move on to the next step of the process. So a flow chart can be used quite easily to find quality problems. You flow chart a process and then locate all those points where there might be a quality check being done. What is happening at that quality check? What kind of data is being gathered? It's very possible they'll be collecting some reports there, some data there. Take a look at those things. And you can do that only if you locate the right spot where that data is being collected. And that can be done only when you've charted the flow of the either information or of material. So a flow chart or a process map really identifies the sequence of activities or the flow of materials and information in a process. Flow charts help the people involved in the process understand it much better and more objectively by providing a picture of the steps needed to accomplish the task. Certain symbols are used, and the symbols are given as operation, transportation, inspection, storage and delay. Out of all these things, the one that is really important is the operation. The rest of it is all really supportive. Everything else is supportive. Except for operation, no other place I'm adding value. So this is the part that I should really be focusing on. If there are any of these other things involved in the process, I should try to eliminate them. That's what I should try to do. I'll give you an example. And I list out some of the benefits which you can really look up by just reading them. Let's take a look at one of the examples. There was a simple travel authorization process in a company, and this authorization process had been in use for many years. For 5-6 years people have been using it, and no one had complained about it, and the people followed this particular track. And it went like there was an operation, then there was a transportation, then there was an inspection done. Again, some operation was there, some transportation, and this, what is being transported here? Some piece of paper actually, which is picked up from somewhere, a little piece of paper on which some material has been written, and that piece of paper is floated through the system, and it goes from one end to the other, and that piece of paper is flowing through and is following this particular chart here. This is how the paper is flowing. The paper is flowing right from the beginning to the end. In the original process, it took about 4 or 5 days for the authorization to come back. It took about 4 or 5 days. If there were no problems, it took about 4 or 5 days for the authorization to come back. This is a very cumbersome and a bad process. Someone drew this flowchart. Before the flowchart was done, of course, nothing was really done. And let me tell you how this was done. Some particular person has a rush job, had a rush job. He had to visit a customer in a rush manner. So what he did was, he filled out the form and then came to his manager, and his manager said, okay, leave it on my table, leave it in the inbox. It was left there. But then this person, he sort of hinted that no, he really wanted to get out quickly. So could he really ask for this little favor there? And could this paper be then taken? Could this paper be then walked through the various departments? And perhaps he could do it himself, or probably the secretary could do it. But he really wanted this paper to go through the total process as quickly as possible, so he could really call up and tell the customer, yes, he was coming or he was not coming or whatever. He wanted to confirm that date there. It turned out that when the paper was traced, it was found out that in normal course of things, it would have taken it 5 days for the paper to travel from one end to the other for the authorization to be complete. Because some top people had to verify a lot of things. If you had any bill, any outstanding bill, if you hadn't really, settled your previous TA account and so on and so forth, all those checks had to be done by accounting people, a bunch of other people, they had to be done. It turned out that when somebody took a good look at the process, he could combine many different steps. And this authorization could be done in 27 minutes. And this, what I show here, is the revised process. Clearly, this was the result of a re-engineering. But of course, the starting point was this flowchart. The starting point was the flowchart from which this re-engineering could be done. This was one tool. And I've got a couple other examples of process flowcharts, which you can see on the screen. The next tool is the run chart. Basically, this is a chart when you start plotting the data as it occurs. Anything that you begin to plot, the moment you start making data visible, you'll find action. This is so easy to see. In fact, it turns out in many cases, the moment I start drawing a chart, other people start noticing these things. If there are any kind of acceptable limit, some tolerance limit set up on the chart there, that's like a high value and a low value. Anything above the high is no good, anything below the low value is no good. Then many people, they will say, and you yourself will start noticing, oh, there is a trend there, and it's very possible that the thing is going to go beyond the limit there. And therefore, what you do is you basically get into the habit of plotting these things. Many times these things are not done, and we do not really react till things are really out of control altogether. So this is a run chart. It leads to quick analysis and trending of data. Then there is something called the Pareto chart. This is also a simple TQM tool, and what it really helps doing is, if there are various types of complaints, let's say there are all kinds of complaints coming from the customers, then you do some diagnostics. You try to find out what could have gone wrong. You do the diagnostics and you classify the different complaints into various types of sources, various types of root causes. And then you find that it turns out in this case that many of the complaints, they could be rooted to design. There is some issue with the design. The other problems really are not that severe, but it turns out design has caused most of the problems there. This is a very, very important sort of message, that you don't really need to worry about all the other issues there. Focus first on design and get that fixed. If you do that, you'll be able to lick up probably 80% of the problem. This is done by something that we call the Pareto analysis. Pareto analysis is a great way to try to prioritize the different actions that you could be taking. And there are certain benefits there that are also listed in the chart here. You can actually see that on your screen there. You can read them later on also if you wish to. Then there is something called the checklist. The check sheet also is a easy data collection method. It's a very easy way to collect a lot of data. And this is done sometimes when you're trying to classify items between good and bad, or you're doing some traffic study or something and you want to categorize the data. And to do it very quickly, you could just create these little check boxes and start checking them. Notice here I put marks here. I put marks here 1, 2, 3, 4, and the fifth one goes like this. Then again I go to 1, 2, 3, and then I wait for 4 and 5. The fifth one is going to go like this and so on. With this I can easily do quick count also. 5 plus 3 is 8. I don't have to count all the bars from one end to the other. I get a blob like this, that's a 5, the next is 3. 5 plus 3, that's going to be 8. Here I've got exactly 5, here I've got 3, I've got a 5 plus 2, that is 7. So it's an easy way to do counting also. Check sheets are again a really easy way to collect data, and this is also something that you could really look up quite easily. And again, you can replay the tape here, you can replay the slides here, and you can really see how I can utilize the check sheet. Then there is something called the histogram. The histogram is a crude distribution of the output. Notice here the shape of the graph there. This tells you pretty well how the output is distributed. Output or anything, in fact, if you want to have, if you get some data coming to you, and you want to just get an idea, an overall idea of the distribution of the thing itself, produce a histogram. We do that quite often. You know, when you do quality control, we do a lot of histogram plotting. And this is a real easy way to try to find out the frequency of various categories, frequency of data in the various categories. So there again, I've given you the benefits and you can look them up, and that will give you a pretty decent idea of whether the distribution is very wide, or is it going to be peaking, or is it going to be spread like this, or whatever it is, you'll get a pretty decent idea of this. One advanced use of the histogram is to try to get an idea of something called process capability. That is like what fraction of your production is beyond the specification limit. That also can be done. If you plot the histogram, if you find that the tails are outside the spec limits, you know right away your process capability is not good enough. You are producing some material that is going to be off spec. Then I'm going to be having the tool. There is a tool called the cause and effect diagram. I must tell you, this is probably the most important tool that we have in the toolkit of 7 tools. And let me show you the picture here, and you'll know right away that this is something you've probably already seen. This is also called the fishbone diagram. I have the effect on the right hand side. I have the effect on the right hand side. I've got possible causes. This tool is used for brainstorming also. So you've got categories like machines, man, environment, method, and material. There could be man-related factors that could be causing that effect, machine-related factors that could be causing that effect, environmental factors causing that effect, or method factors causing that effect, or materials. This is a real easy way to generate ideas what might have caused that problem there. So if there's a quality issue, the cause and effect diagram or the fishbone diagram is a really easy way to try to sort of brainstorm about this. I'll give you a couple of examples. I'll give you an example, and the example is coming right now. The effect is right to the right hand side, and the possible causes, those are put out on the left hand side. I've got the effect on the right hand side, I've got the possible causes on the left hand side. This is the start of your troubleshooting. You're not solving the problem here, but you're brainstorming about factors that might have contributed to that quality problem there. Remember, what is important here is you're speculating at this point. You're not solving the problem, but you're brainstorming, and this is used then in brainstorming. And here's a little brainstorming group, and they have formed a little quality circle, and they're brainstorming, and the tool they are using is now the cause and effect diagram. That's what they're using. So they are using the cause and effect diagram to do their brainstorming. Then of course, many times there are ideas that can come from benchmarking. This is also another great way to generate good ideas. So besides brainstorming by a cause and effect diagram, you could also look at other processes which are running much better than yours, and from that get ideas. And I've given you names of some of the companies which actually stand out as role models in benchmarking. Suppliers can also give you a lot of ideas, and that's like another place where you can solve, where you can find ideas toward solving your problem. That is also there. Again, if you come back to the cause and effect diagram, here's an example where there were delays in a company's delivering goods to the customer. What did they do? They got to the people who were closest to action. These were the drivers, the loaders and the drivers. And what they found was, my God, there were a whole lot of factors that nobody thought of, and that any of those could have caused a delay in the delivery of the truck. If you track down any of them, shipping documents could be fouled up, the trucking operation itself could be fouled up, packing could be bad, or the container labeling, that also could be bad, because of which you have delays in delivering the customer. This was generated by drivers. Notice here, drivers and dispatchers, they provided the input, and people were able to generate this thing. This would be the start. What I've got here as the cause and effect diagram, this is the start of solving the problem. This by itself is not a solution. It might lead to a solution. But what we are pointing out is that this is a brainstorming tool. You basically speculate about possible causes. And here's another example where we've got some problems with air travel, and we want to really try to improve the level of that air travel quality there, and for that we go after that. Now suppose I've got a cause and effect diagram, and I look at one of the factors there. I look at, for example, some aspect that is there, and that could have caused a problem. I could draw a quick, what we call a scatter diagram. I put the factor down here, I could put the effect down here, up here, and I could really see, is there a relationship between these two? If there is some relationship, then I've got a handle now on the problem. The problem is here, the problem is on the y-axis, and I've got my control factor on the x-axis. With this, I'm likely going to be able to control the effect. That's like one great way to try to tackle quality. I've given you a couple of examples here for doing this. Then this last chart, this is called the control chart. This is SPC, Statistical Process Control chart. This I'm going to be discussing in great detail when I discuss SPC with you. But it's a way to try to remember two things we mentioned. We mentioned the issue of accuracy, and also we mentioned the issue of precision. In a general manufacturing process, both of these could be problems. I could have problems of accuracy. I could also have problems of precision. Both of these can be kept in control by use of the control chart. The control chart itself becomes the greatest tool for doing this. There are two types of charts used here, the X bar chart and the R chart. I'm going to be giving you details on them. So where am I now in regard to my march on quality? I'm right down at SPC when I'm talking about control charts. And control charts, they are a great way to try to keep a process in control online. Very, very important. And there are certain signals that are provided by the control chart. And if you keep going this way, if you have a control chart that's also partially automated, because automated data collection is possible in many cases, you must start with a chart that starts with a wide variation, showing initially that there is poor precision, also poor accuracy. As you move slowly toward it, your precision may improve and also your accuracy may improve, and you end up with a much, much better process. This is really where you'd like to go to. So the 7 tools that we've looked at, this is basically a summary of it. We've got the run chart, histogram, control chart, Pareto chart, flow chart, scatter diagram, and the cause and effect diagram. They are the tools that can be used by almost anyone on the shop floor. And the Japanese make sure their workers are trained on each of these tools and they use it. I'll continue with this, and let's just take a small break and then we'll go on to the next lecture. Thank you very much. Thank you.